Why turn right 45 degrees? Thank you, Diego. So why do we rotate the constellation by 45 degrees to the right? Let me explain. As Diego mentioned, the angular separation between symbols is 11.25 degrees, and because the phases are very close, the probability of error increases if the channel has noise. Now, rotating the constellation by 45 degrees or minus 45 degrees to the right represents a change in the phase reference frame. This is important to understand. This rotation does not alter the transmitter data or the fundamental properties of the modulation. Example: shifts all symbols phases by a constant offset. You can see in this diagram on the left how the constellation looks with 45-degree rotation. Notice how the symbols are, are no longer aligned with the A and Q axes. System characteristics. Let's look at the system characteristics of 32 PSK. First, spectral efficiency achieves achieves 5 bits per symbol, proving excellent bandwidth efficiency. This, this makes it suitability for applications where spectrum is limited but high data rates are required. Second is an error requirements due to the close spacing of symbols. 32 PSK requires approximately 18 to 20 dBs SMR to achieve a bit error rate of 10 to the minus 6. It's important to note that the 45-degree rotation is a phase reference choice and does not significantly change the verb performance compared to not rotate configuration because the relative distances between symbols remain the same.
Thanks, Nicholas. Let me walk you through the key parameters of our 32 PSK system. First, the symbol rate. The 32 PSK system transmits 5 bits per symbol. As we calculated before, log base 2 of 32 equals 5. This high density allows for efficient use of available bandwidth, making it ideal for bandwidth-constrained communication system. Second, phase separation. Adjacent symbols are separated by 11.25 degrees, which is 36 divided by 32. Third, applications. 32 PSK is commonly used in satellite communications, especially in DVB-S2, standard high-speed modems, microwave links, and other systems, requiring high spectral efficiency with acceptable power requirement. Finally, performance where 32 PSK offers excellent spatial efficiency. It requires a high signal to noise ratio to maintain acceptable error rates. The system acceptable error rates performs best is enable high quality channels. Now let's see what the 32 PSK signal looks like in the in the time domain. In this graph, we can see the 32 PSK signal over time. The key thing to notice is that the amplitude stays constant, but the phase changes to each symbol interval. Each vertical line marks the beginning of, of a new symbol with a different phase. You can see the phase angles labeled above, for example, minus 45 degrees, 11.2 degrees, 90 degrees, and so on. The vectors of the origin show the phase angles, and this helps us to visualize the signal mapping. Notice how the waveform shifts at each symbol boundary. That shift presents a different phase and therefore different data. Now, Juan will show you the phasor diagram and discuss the advantages and conclusion. Sorry.
This is the phasor diagram for 32p A phasor diagram shows vector from the origin to each symbol points. This representation has several advantages. First, the vector from original glare show the magnitude and direction of each symbol. Second, it shows the exact phase direction of all 32 symbols. Third, it is useful for analysis, modulation, behavior, and understanding how do symbols relate to each other. Advantage and disadvantage. Let's discuss the advantage and disadvantage of 32 PSK on the advantage side. First, high spectral efficiency. We hit 5 bigs for symbol, which is excellent. Second, it's useful for channel with good signal to know right where we can take advantage of the efficiency. Conclusion. To conclusion, the implementation of 32 PSK with 45-degree rotation successful demonstrates the modulation technique with clear visualization of constellation geometry and signal behavior. The 45-degree rotation represents a phase reference adjustment that means the summed relative distance between symbols. While this rotation can help avoid axis line sensitivity in certain hardware implementation, the fundamental bit error rate performance remains equivalent to no rotate 32 PSK. The modulation of high spectral efficiency at 5 bytes per symbol would require high SNR around 8 to 10 dBs for related operation in practical communication system. This makes it sought for high quality channel like satellite link and point-to-point microwave system. And thank you for your attention. We now have to answer